Yeah, we're here to review for benchmark 5. So hopefully you've already done this, and this will help you through any problems that you got stuck on. So first things first, we need to know our formulas. So these are some basic formulas you need to know, and these should be just as easy as finding them in your notes and copying them down. So the distance formula, you can't miss the little things like the subtraction signs in the parentheses, the squareds outside the parentheses, and then the plus sign. And the square root goes over the entire thing. Midpoint formula, remember, there is no equal sign. M is just the name of the midpoint. Midpoint we are adding. It's a common mistake to subtract. There we have it. We got to have parentheses, a comma in between, add the x's, divide by 2, add the y's, divide by 2. We could actually get the endpoint formula from the midpoint formula, but it's just as easy to probably remember. I have two endpoint formulas. We're looking for x2. That's 2 times xm, which is the x value of the midpoint, minus x1. And similarly, we have y2 is 2 times the y value of the midpoint, minus y1. And last but not least, the slope, which is little m, is y2 minus y1 over x2 minus x. The most common mistake made here is that you put the x's on top instead of the y's. And again, we have subtraction. So you should memorize these formulas. They'll be helpful, especially once we get to the end of the year. Done for these four, A, B, C, and D. All I wanted you to do was write the equation that you would write in order to solve for x. So in this case, if I want to find x, I need to write an equation. My formula is ow equals ow. But I want to know what's the exact equation I would write. The outside of this secant is 3. The whole thing is 3 plus 5, which is 8. The outside of this secant is 4. The whole thing is 4 plus x. So this is what your answer should look like. I didn't need you to solve it. I just want you to be able to set it up. Same thing over here. We don't have ow, ow now. These two chords intersect inside the circle. So we have a little piece times a little piece, 4 times x, equals 5 times 8. And that's all you need to write. If you did 4 times x equals 40, that would be acceptable as well. So no need to solve for these. For C and D, here my relationship is that the measure of the angle is equal to the big arc minus the small arc over 2. But I want to know what exactly I should write to find the angle. Well, the angle is question mark, and it's going to be the big arc 129 minus the small arc, which is 61 over 2. So remember, the angle is the angle formed between the two segments, and the arcs are the pieces of the circle that are cut by the two segments. So right there, 129, and the other one's 61. When I have two segments that meet inside, it's the angle is equal to arc 1 plus arc 2 over 2. So a plus sign. Common mistake is still subtracting. So my angle is question mark, and that's equal to the two arcs, and they got to make sure that they're the arcs that are kind of part of this bow tie here, which they are, 175 plus 55 over 2. And again, all I was looking for in these two were the equations you would write. No need to simplify in this point. Here you want to find the area of the sector. These ones I am actually going to solve. So the formula for area of a sector is the central angle measure or the arc measure, which are the same since this is a central angle. That angle over 360. We're going to multiply that by the area of the entire circle. Remember, the area of a circle is pi r squared. So we take this piece and put it over here, pi times the radius squared. We can do some simplifying, 270 over 360. Oops. We'll simplify that in a minute. 13 squared is 169. Now we can multiply 270 times 169 and divide by 360. And we get that area of this sector is 126.75 pi feet squared. So you can simplify 270 over 360, multiply it by 169, and then we want to leave it in terms of pi, so we have to attach the pi there or else we're not correct. And we're talking about feet here, so we should say feet squared. Very similarly, this time we want to find the length of the bold arc. 270 is the measure, so in degrees, the arc measures 270 degrees. We want to find out how long it is. So if we were to cut this circle right here, let's say, how long would it be from this point to this point if we stretch that thing out straight? So again, we do 270 over 360. And this time we're going to multiply that by the circumference of the circle. Circumference, remember, is 2 times pi times the radius. So we take that, multiply by 270 over 360. 2 pi, the radius is 13. And now I can do 270 divided by 360 and multiply that by 26. And I get 19.5. And again, we're leaving in terms of pi, so we didn't multiply by pi, so we're going to put it next to it. 19.5 pi feet. That is how long it is from this point all the way around to that point. So that's a measure in feet, whereas the measure of the arc is in degrees, so you can see the difference. You don't want to write the equation of a circle. As a reminder, the equation of a circle is on the formula sheet, so you should always go and start by copying that thing down. There's also a nice picture that shows you that HK is the center and R is the radius. So in order to fill this in and write the equation, we need to find the center and the radius. Well, luckily, we're given the center, 6, -2, so we can plug that in for H and K. So 6 goes in for H. Negative 2 goes in for k, so minus negative 2 gives us plus 2. Now we're left to find r. At the end of this, we want our answer to look like x minus 6 squared plus y plus 2 squared equals some number squared. So I'm going to make sure that I know what I'm answering. And I'm going to go ahead and start my answer over here, and I'll box it in. So I know part of my answer is x minus 6 squared plus y plus 2 squared equals something. We have to find out what that r squared is. We have here that gotta reveal it. We have a point on the circle that's 3, 2. So that means that we should be able to plug 3 in for x and 2 in for y, and we'll be able to find r. So let's do that. So I'll go back over here to my unfinished equation, and I'm going to do this just to help me figure out what r squared is. So my x was 3, my y was 2, oops, sorry again, so I keep my h and k in there, I plug my coordinates of my point that's on the circle in for x and y, and that's going to help me find r squared. So I can just simplify this side now. And I get that r squared is 25. So notice again, this thing I circled over here is r squared. So I can actually just take the value of r squared, which is 25, plug it in over here, and now I have my equation of the circle. An alternate answer would be, if I were to actually find r, I could square root both sides here and get r to be 5. So then my answer would be x minus 6 squared plus y plus 2 squared equals 5 squared. Both of those answers boxed in are completely acceptable. One gives us r squared as 25, the other gives us r squared as 5 squared. These two values are the same, they just look different. Both are acceptable answers. So at the end here, we want an equation, so we need an x and y. So if you're done and you circle an answer and there's no x and y showing, then you need to make sure you go back and fix that because you've made a mistake. Okay, I'm going to have a picture below here. I'm trying to find x that makes L parallel to M. So I want L to be parallel to M, so I want this situation. These two angles are corresponding angles. Corresponding angles are congruent, of course, so that means their values are equal. So we can write this simple equation and solve it for x. And get that x is 30. And of course, we plug x back in here. 30 plus 25 is 55, and they're equal. So if these two angles are both 55, which means x is 30, then these two lines, L and M, will be parallel. Here I can see, well, it's maybe a little bit difficult to see. I have these little arrows here on those lines. That means they're parallel. So that means all my parallel angle pairs exist here. So if this is 51, then angle 7 is 51. They are vertical angles. 5 is 51 because they are corresponding angles. This guy is 51, another pair of vertical angles. 2, angle 2, and this one that's 51 degrees, they should be supplementary because they're same side interior angles. So that makes this one 129. And you can kind of follow the pattern now to fill in all of the missing angles. So there's 8 angles in total, and there's only 2 different degree measures. You can almost see the pattern, and we know that is true because of the 2 arrows here that tell us these lines are parallel. Next 2 questions are graphing questions, and both of them deal with finding slope and then drawing a line either perpendicular or parallel. So I'm going to answer 8 and 9 on the same graph so that you can see the difference. Both of them ask you to draw a line through the point negative 2, 2. So we're going to start by finding negative 2, 2, and I'll label it. And in order to draw a line parallel or perpendicular, the first thing I need to know is the slope of the line that I'm drawing it perpendicular or parallel to. The easiest way to find slope, especially if I have points on a line on a graph, is to start at one point. I usually start at the leftmost point because if I go down, that tells me the y is negative. 1, 2, 3. And right is positive 2, 3. So that means the slope of this line is negative 3 over 3. Remember, the rise or the y is on top, the run or the x left to right is on the bottom. So now, I know my slope is negative 3 over 3 for this line that I already have. Now I need to graph the parallel and the perpendicular. The slope of the parallel line is going to be the same. It's going to be negative 3 over 3. The slope of the perpendicular line is going to be a bit different. First thing we'll do, this whole fraction is negative, so the perpendicular slope is going to be positive. And now I'm going to take these 2 numbers, 3 and 3, and I'm going to flip them. So I still end up with 3 over 3. So my perpendicular slope is positive 3 over 3. So now let's graph these. Start with the parallel line. I start at the point that I want my line to go through. I go down 3, to the right 3, draw a point. And now I can draw a line parallel. And you can use your calculator. Cap as a straight edge. Perpendicular, again, I start at the point I want to go through. This time I'm going up 3, to the right 3, and I have a line perpendicular. So these questions 8 and 9, they're all about slope. You got to find the slope of the line you're given, and then you have to know that parallel lines have the same slope. Perpendicular lines, you flip the fraction and change the sign. So we can skip 9 since we just did it, and we'll go right on to 10. Number 10, I'm told these 2 angles, angle MLN and angle JLK, are complementary. That means that they add to 90 degrees. So that means that this MLN and this JLK should add to equal 90 degrees. So I'm going to set that equation up. 7x minus 1 plus 4x plus 3 equals 90. And now I just have to make sure I don't make any algebra mistakes. And then, of course, I answer the question being asked. We'll go back to that. So 7x plus 4x gives me 11x. Negative 1 plus 3 gives me 2. Subtract 2 from both sides. Divide both sides by 11, and I get x to be 8. Now let's go back and let's see what I was actually asking you to tell me. I wanted you to find the measure of JLK. JLK was 4x plus 3. So I'm going to go plug 8 in for x there. So 4 times 8 plus 3, which is 32 plus 3. The measure of angle JLK is 35 degrees. So finding x was good. Plugging in and getting 35 is better. That's the answer I'm looking for. This problem, I'm looking for the value of x only. I have to understand this relationship. I have two interior angles in a triangle, and then I have a remote exterior angle. Over here. It's remote because it's away from these two, and it's exterior because it's on the outside of the triangle. And the relationship here is that this remote exterior angle is equal to these two interior angles added together. I actually switched up the vocabulary. I apologize. These are remote interior angles. They're remote from the exterior angle. But the idea is the same. Just a little slip of the vocabulary. We all make mistakes. Hopefully some of you could have corrected that mistake for me. So let's simplify and solve for x. Subtract 3x from both sides. Add 10 to both sides. And I get that x is 35. I don't need to plug back in because all I asked for was x. And I will cross that out and I'll point over here because remember, those are remote interior. My bad. Number 12, hopefully is a dream. We're finding the value of x. These are all interior angles. All of them should add up to 180. All the angles in a triangle add up to 180, so let's do that. This simplifies into an algebra problem. 59 plus 51 gives me 110, plus 84 gives me 194. Subtract 194 from both sides and get 2x to be negative 14. Divide by 2 and get x to be negative 7. I'm just finding the value of x, so we're okay. The negative might throw you off a little bit, might make you think you're wrong. The easiest way to check is to take negative 7 and plug it back in to both of those angles and make sure all three of these angle values add up to 180. So this angle would become 52. This angle would become 46. 46 plus 84 is 1. Well, I'm sorry, not 46. It's late at night, I'm slipping. It would be 44, I apologize again. So 44 plus 84 is 128, plus 52 is 180. We're good. So it might be worth checking twice. I've shown now twice in a row. It's easy to make mistakes. So hopefully if you've gone through this packet once, you're going through again today and going over again maybe one more time before the test so that those little silly mistakes get eliminated. This problem I noticed was tricky for some people. We have to make sure that we read the whole question or the whole statement here, angle B congruent to angle C. Just like when we're doing proofs in class, let's put this information on the picture. Angle B is congruent to angle C. That makes this an isosceles triangle. And the sides opposite the congruent angles are also congruent. So I can write an equation 3x minus 4 equals x plus 10. Subtract x from both sides. Add 4. Divide by 2. And get the value of x to be 7. In the event where I would be looking for the perimeter of this triangle, all I would need to do is plug 7 in for x in all of these expressions, and then add them all together. But in this case, all I want is the value of x. Here I want to decide which theorem I would say these two triangles are congruent by. So again, this is something we did more simply back in the congruent triangles unit. We've been doing a little bit here with proof. So I have one pair of congruent angles. I have a pair of congruent sides. And I know that these two angles are congruent because they're vertical. That gives me a second pair of angles. So I have these two congruent by angle side angle. In this problem, I want the statement that we would need to know. So what would we need to know in order to say these two triangles are congruent? Well, I know that these two 90-degree angles are congruent. I know that this side is congruent to itself because of the reflexive property. So these are things that I know just by looking at the picture. I want to know what you would need to know. What extra information would you need to be told to know these two triangles are congruent by side, angle, side? Well, right now I have a side and an angle. I need the sides that include the angle. So I would need to know that side or segment WV is congruent to XK. And this is the answer I'm looking for. Here are new sort of questions. I have 3 boats, but really I can reduce this problem down to a triangle. And it's pretty plain to see. So I can kind of ignore the boats in the bay. All I need to know is the names of the vertices. So I want to list the lengths from longest to shortest. So the longest side will be across from the biggest angle. So my first task is to find out what this angle is here. And the easiest way to do that is to subtract those two angles from 180. So 180 minus 58 minus 68. That angle is 54 degrees. The smallest angle. The biggest angle is 68. So the side across from 68 is AC. That's the longest. I'm just going to list them. Next biggest angle is 58. The side across from that is BC. And last but not least, the side across from angle that is 54 degrees is AB. Pay attention. I wanted longest to shortest, so my longest needs to be first. In 17, I want to know really what one possible length for a triangle is if the triangle has one side that's 60 and one side that's 24 inches long. So we can find the range of possible lengths just by subtracting these two. 60 minus 24 gives us 36. And adding them, 60 plus 24 gives us 84. Our third side has to be somewhere between these two lengths. It cannot be 36, it cannot be 84, it has to be something between the two. So you could give me any number of answers. For example, I could say 37, or I could say 83, or I could say anything else between 36 and 84. You might say 51.2. All of these are acceptable answers. We all probably could answer differently and still be right as long as it's between 36 and 84. In this question, I was trying to ask you, is this triangle right? Is it obtuse? Or is it acute? The way we figure that out is by using the Pythagorean Theorem. And remember, I put a question mark over my equal sign because I don't know if both sides are going to be equal in this case. So my biggest side goes in for C, that's 7. My other side's going for A and B. Oops. Got ahead of myself. Four squared is 16, plus 5 squared is 25. Sixteen plus 25 gives us 41. And 41 is less than 49. So if my a squared plus b squared side is less than the c squared side, so that means c squared is bigger, then this is an obtuse triangle. So if you do a squared plus b squared equals c squared, and there's a less than sign, it's obtuse. This is just like 2 problems ago. We want to find out the third side length should be between what two values of if this triangle has a side that's 10 and 17. So it's somewhere between 17 minus 10, which is 7, and 17 plus 10, which is 27. Somewhere between those two values. And to make sure you get credit, you should show some work. It also helps you remember what you did. The proper way to write this at the end would be something like that. Our third side, we'll call x, is greater than 7, less than 27. Two more problems here. Here we want to know the length of DC. That's that length. If AD is an altitude, so AD is an altitude. Well, we need to remember that an altitude makes a right angle. So that means that this 4x plus 10 is equal to 90 degrees. And that's going to help us find x. Subtract 10 from both sides and divide by 4. Now all we need to do is plug in. DC is 3x minus 4. So we plug 20 in. DC is 56. So, like in some math problems, 2x was extra. We didn't need it. It wasn't there to confuse you. It was just extra information. Finally, onto the last problem. We see that DE is the perpendicular bisector of AC. So that means two things. DE is perpendicular to AC, and it bisects AC, which means these two segments are congruent. So the congruent part is going to help me find x, which will help me find the length of AC. So 6x minus 2 is equal to 7x minus 9. Add 9 to both sides. Now I get x to be 7. And if I want to find the length of AC, I can just plug 7 in to just one of these. If I plug 7 into one of these, I'll figure out what both of them should equal, since they should both be the same. So I'll plug it in right here. So that means this piece is 40 long. So that means the other piece is 40 long. So AC is 40 plus 40, which is 80. So my hope is that you had tried this already on your own, and that this review video helped you get unstuck if any of these problems had you stuck. Remember, this review packet is due for a grade at the beginning of Wednesday and Thursday before the benchmark. It will be a grade, and of course then you have the benchmark on Wednesday and Thursday.